All right, now that we have a basic way to complete the square, we're going to apply this for circle equations. So let's consider the equation x squared plus 3x plus y squared minus 4y is equal to 0. Now this is an equation for a circle in general form. This doesn't necessarily give us a quick or easy way to read off either the center of the circle or the radius of the circle, but we can do that by changing the form of the equation. Now what we're going to do is essentially a completing the square exercise, and what we ultimately want to get this into is something of the form x minus h squared plus y minus k squared is equal to r squared. Now, if you were to try to line this up in a rather crude manner, you might say h is 3 and k is 4 and r is 0, but that's not correct. Now, the way that people came up with the completing the square method, or at least one way to generate it, is to work backwards. That is, instead of starting from the initial problem and doing a bunch of steps that may or may not make sense, start from where you want to ultimately get and backtrack until you get to exactly what you're looking for. So in this case, what we're going to do is we're going to multiply this out, and we're going to line it up with this, and that's going to tell us how to solve for h and k, and then we can go ahead and solve for r in a minute. So if we multiply this out, this is FOIL, so we have x squared minus 2hx plus h squared plus y squared minus 2ky plus k squared is equal to r squared. All right? Now what we do is we line this up. So we'll notice that the x squared is the same as the x squared. We'll know that the 3x, well, that should be like the negative 2hx. So if we look at this, we need 3x is equal to negative 2hx, which means that 3 needs to be equal to negative 2h, or h is equal to negative 3 halves. Likewise, if we line negative 2k up with negative 4, we'll get negative 4 is equal to negative 2k, and that means that k is equal to 2. So right off the bat, we can actually find the center of the circle. It's going to be negative 3 halves, because that's going to be our h, and 2, because that's going to be our k. So this is where the center of our circle is going to be. But that doesn't complete all the work for us. If we compare this line with this line, we'll notice something else. We're missing an h squared, we're missing a k squared, and if the radius of the circle is 0, that's just a point. And I don't think that this is going to be a point, or at least I'm not sure, at least looking initially at this equation. So what we need to do is we need to include some sort of h squared, and we need to include some sort of k squared. So if we consider h squared, that's negative 3 halves, so that's negative 3 halves squared. That's equal to 9/4. And then if we look at k squared, that's just 2 squared. That's going to equal 4. Okay, so we figured out the appropriate h and k for this specific circle equation, and now we need to figure out some way to include the h squared and k squared. So if you'll notice, I still have this same equation all along the top of the board, but now I've stretched it out. And the reason that I've stretched it out is that I noticed that if I want this to line up with this, and this to line up with this, I need there to be an h squared and a k squared terms right there. So what I'm going to do is I'm going to add those terms. So if I want to add h squared, well, I figured out that h squared was 9/4, so I'm going to add 9/4, and I'm going to subtract 9/4. Now, if you notice, I haven't changed anything about this equation because I've only added 0, but I now have an h squared over here. Likewise, I can do the same with k squared. So if I know that k squared is 4, I'm going to add 4, and I'm going to subtract 4. Now, if we look at this, this is closer to what we want, but if we notice, we have an extra negative 9/4 here. That is, there is no minus h squared here, and there's a negative 4 over here, and there's no negative k squared over here. So what we're going to do is we're going to add 9/4 and 4 to both sides of our equation so that we get something closer to looking like this. And if we write that down, we get x squared plus 3x plus 9/4 plus y squared minus 4y plus 4, and that's going to be equal to 9/4 plus 4. Okay? Now, if I look at this, this is x squared plus 3x plus 9/4, and that's exactly x squared minus 2h plus h squared. So I can rewrite this term as x minus h, which is negative 3 halves, and that's going to be squared because that's what I had from here, plus y minus 2 squared, which will be this right here. And then if I look at this, I have 9/4 plus 4. So if I add those together, that's going to be 16 over 4, so that's going to be equal to 25 over 4. Now if I look at this, this is now in the same form as this equation here, where h is equal to -3/2. Here we go, -3/2. K is equal to 2 minus the 2. And now we have our r squared. So if we wanted to find the radius, we'll notice that our r squared is equal to 25/4. And so when I square root both sides, I'll have r is equal to, the square root of 25 is 5, and the square root of 4 is 2. So that gives us the radius. And these two bits of information gave us the center, -3/2 over 2. And so that completes the process of completing the square for circles. If you notice, what we did in these steps up above was that we took the coefficient of x, we took half of it, so in this case it's 3/2, and technically we took a negative, but that won't matter because we're going to square it. And that gives us the plus half squared minus half squared, which is exactly what we did in the previous video. Likewise, we took -4, we took half of it, and technically we took the negative half, and then we squared it and added it and subtracted it. And so the procedure that we had from the previous video lines up exactly with what we did here. We just moved the bits over so that we can complete the square on these terms, complete the square on these terms, and then the bit that's left over is exactly the radius squared. And that's how you convert a circle equation from a general form into a standard form.